Good morning, students. I am Sangeeta, lecturer in chemistry, branch general section, Institute GPT Naramkhed, semester 1, subject general engineering chemistry, subject code 18C104F. Our major topic is water technology, and that subtopic is ion exchange process. Let us recollect what we have discussed in last class. So what we have discussed in last class? In last class, we discussed zeolite process. Okay, what is zeolite process? So why it is called zeolite process? The chemical used in this process is called zeolite or permitted. That's why it is called zeolite process or permitted process. So this chemical, this zeolite, we are packing in one container. So in that container, we are passing hard water. So when hard water is passed onto that zeolite, what is happening? Whatever the calcium and magnesium ions present in this hard water will combine with zeolite and convert into calcium and magnesium zeolite. So like that, water is becoming soft. So that soft water will come above, and after some time this zeolite will exhaust, and this exhausted zeolite will be regenerated by passing 10% NaCl solution, that is brine solution. Then again permitted is regenerated. Like this we will do the zeolite process, and after regeneration we have to wash this zeolite with little water. Okay, this is about zeolite process. So today we will discuss with ion exchange process. So what are the objectives? After completion of this topic, you would able to understand whole ion exchange process and advantages of ion exchange process. So we will see the ion exchange process, or it is also called as demineralization. Demineralization. What is mean by demineralization? The process of removal of mineral salts from water is called D. D means removal of mineral salts from water is called demineralization. So here ions are exchanging. So that's why it is called as ion exchange process. So the process. This is recent and widely accepted method. In this method, long chain organic polymers called resins are used. So this is the widely accepted method and very recent method. So in this, what we are using? We are using organic long chain polymers. So organic means it is made up of carbon and hydrogen. Main skeleton is made up of carbons and hydrogens. It is a very long chain. Its molecular weights will be very high. Polymer. Poly means many molecules are joining together and you are getting a very huge structure. So those organic polymers called resins are used in this process. So based on nature of functional group, resins are classified into two types, that is acidic resin and basic resin. So whatever the functional group present in that one, so based on the nature of that functional group, nature means whether it is acidic in nature or basic in nature. So that's why resins are classified into two types, that is acidic resin and basic resin. So for acidic resin, these two are the examples. COOH, this is carboxylic acid group. This is sulfonic acid group. So either if functional group is acidic nature, that is acidic resin. If functional group is basic in nature, that is NH3 group or OH group, that is basic resin. So These two types of resins are used in this process, that is acidic resin and basic resin. Okay, so resins are taken in two containers. So here we are using two containers, whereas in zeolite process we used only one container. So here we are taking two containers because we are taking here two types of resins, no? So that's why we are taking two containers. Acidic resin one container and basic resin in another container. So acidic resin in one container and basic resin in another container. Okay, when hard water is passed through acidic resin. So we are taking two containers. In two containers, we are keeping one resin. So in first container, we are keeping acidic resin, and in the second container, we are keeping basic resin. So first, we are passing hard water into the container which is having acidic resin. That means through acidic resin we are passing the hard water. So when you pass hard water onto the acidic resin, so what is happening we will see here. So when you pass hard water into the acidic resin, calcium plus 2 and magnesium plus 2 ions present in hard water are exchanged with H plus ions present in the resin. So when you pass hard water onto the acidic resin, what is happening there? So whatever the calcium and magnesium ions. So see here, calcium and magnesium, positive ions. That means cations present in hard water are exchanged with H plus ions present in the resin. So whatever the resins we are taking here now, RCOOH, H plus, RSO3. So these H plus ions present in this resin are exchanged with what ions? These calcium and magnesium ions present in the hard water. So hence acidic resin are also called cation exchange resin. So that's why these acidic resins are also called as cation exchange resin, because it is exchanging cations present in the hard water. This hard water is exchanging, sorry, this acidic resin is exchanging which ions? Cations present in the water. That's why acidic resin is also called as cation exchange resin. Then the water is passed through anionic exchange resins where Cl minus and SO4 minus 2 in hard water are exchanged with OH minus ions. So first we are passing hard water onto the acidic resin. There what is happening? The acidic resin is exchanging cations present in the hard water. So with what they are exchanging? With H plus ions present in the hard water. So that's why acidic resins are called cation exchange resin. That means that acidic resin will take these two ions and liberates H plus ions. Then the water is passed into the anion exchange resin. So that water will pass to the another container having anion exchange resin. So here in first container, the cations are removed off. It is taken. So remaining, what are the ions present in hard water? So that water containing H plus ions and anion Cl minus SO4 minus 2. So hardness is due to either calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. So what are the anions may be present here? Either chloride ions or either sulfate ions. So the chloride and sulfate ions present in hard water are exchanged with OH minus ions present in the basic resin. So here what is the resin we are taking? OH or NH3. If it is NH3, and it will exchanges with NH3. If it is OH, it will exchanges with OH minus ion. So what happens there? in hard water are exchanged with OH minus ions. That means basic resin will take these anions and liberates OH minus ions. Okay. So acidic resins takes these cations and liberates H plus ions. Whereas basic resin will take Cl minus and SO4 minus 2 ions, that is anions, and liberates OH minus ions. That's why this basic resin is also called as anion exchange resin. That one is not given here, so it is also called as anion exchange resin. So the H plus ions and OH minus ions so produced reacts together to form water. So here acidic resin will liberate H plus ions, whereas basic resin will liberate OH minus ions. So whatever the H plus ions and OH minus ions produced reacts together to form water. So this is the process happening in the ion exchange process. So here we'll see the reactions. Okay. So here when you pass acid onto the acidic resin. So this is the acidic resin. These may be the ions, cations present in the water. So what they will do, they will take these cations and they will liberate H plus ions. That means these H plus ions are exchanging with calcium and magnesium ions like this. Calcium resin and magnesium resin will be formed and H plus ions will be formed. This is cation exchange resin reaction. Okay. And anion exchange resin. So here anion exchange resin, we have basic resin is ROH. Cl minus SO4 minus 2 ions are present. They will take these two anions and liberates OH minus ions like RCl, R2, SO4 will be formed. Okay, so we will see this. Then cationic and anionic resins are existed after some time. So if you repeat this process continuously, if you continue the process for 24 hours, what happens here also? Is cationic and anionic resins are exhausted. That means there are no H plus ions and OH minus ions to give. So when they exhausted, again we can regenerate, same as zeolite. So there also after exhausting zeolite, we are regenerating zeolite. Here also we can regenerate cationic and anionic resins. So exhausted cationic and anionic resins are regenerated by adding acids and bases respectively. Okay, we can regenerate this cationic resin and anionic resin. How? By passing acid, we can regenerate cationic resin, that is acidic resin. By passing base, we can regenerate this basic resin, that is anionic resin. So how will you regenerate? So we will see here. So whatever the products formed here, this during this exchange of cations, this product is formed, they will remain there only. Okay. So during the anionic reactions. So whatever the products from, they will retain in the tank itself. Okay. So there what happens when you add acid, these acid will react with this one. Then you will get acidic resin and some byproducts, that is a calcium chloride. If it is a magnesium chloride will be found. So like this you can regenerate acidic resin. Similarly, you can regenerate basic resin. How basic resin is regenerated? When base is formed, NaOH, strong base, NaOH, their strong acid HCl. So when base is passed, then anionic resin is formed and byproducts NaCl. If Cl is there, NaCl is formed. If R2SO4 is there, Na2SO4 is formed. Like this, you can regenerate acidic and basic resin. So this is the diagram for ion exchange process. So these are the two containers. This is the first container. This is the first tank. This is the second tank. In first tank, we are keeping the acidic resin. In second tank, we are keeping the basic resin. So first we are passing the hard water onto the acidic resin. So what happens here? only cations present in the hard water are exchanged by H plus ions of acidic resin. Then the water containing H plus ions and anions will move to the next tank, and whatever the products found they will retain in the tank only. So here some gravels will be filled here, fine gravel will be filled here, coarse gravel will be filled. Fine means small granules, small size stones. Here somewhat big, coarse means somewhat big size gravel. So they will act as filter beds. So here after removal of cations, the water will filter through these filter beds and move to the next container. Then after coming to the next container, here what is there? Basic resin is there. So that basic resin will react with the anions present in the hard water. That means anions will be taken away by that basic resin, and OH minus ions will be liberated. The H plus ions produced in the first tank and OH minus ions produced in the second tank, they will combine and form water. Okay, so then after few hours the resins will be exhausted. So after what you have to do, you have to pass acids and bases. To regenerate acidic resin, you have to pass acids. So that is dilute solutions, not concentrated. Dilute solutions will be passed. Dilute HCl is passed through one inlet, and again acidic resin is formed. When dilute NaOH is passed, then basic resin is formed. So whatever the acidic and basic resins will be formed. Then soft water will be removed off from this outlet. Okay, this is cation exchange resin. This is anion exchange resin. That's here cations are removed off. Here anions are removed off. So total mineral salts are removed off. That's why this water is called as demineralized water. That's why this process is called as demineralization process. And here ions are exchanging. Okay, cations are exchanging with H plus ions, anions are exchanging with ions. That's why ion exchange process. So this is the diagram for ion exchange process. Okay. So once again I will repeat. So two resins we are using, that is organic polymers called resins, acidic and basic resin. So acidic group, if acidic group is present as functional group, that is acidic resin. If basic group is present as functional group, that is basic resin. These two resins we are taking in two containers. So acidic resin in one container called as cation exchanger, and basic resin in another container called as anion exchanger. First hard water is passing through acidic resin. Their cations are exchanged with H plus ions. That's why this resin is called cation exchange resin. Then the water is passed through anion exchange resin, where anions are exchanged with OH minus ions. That's why basic resin is called anion exchange resin. The H plus ions produced in the first tank and OH minus ions produced in the second tank combine to form water molecule, and these are the chemical reactions taking place in cation exchange resin. Just cations are exchanged with H plus ions. They will take this resin will take the Ca plus 2 ions and liberates H plus ions. Similarly, Mg plus 2 ions it will take and liberates H plus ions. Then anion exchange resin, just they will take the anions and liberates the OH minus ions. Okay, again by passing after few hours it will be exhausted. So exhausted resins are again regenerated by passing acids and bases. By passing dilute HCl, we can regenerate acidic resin. By passing dilute NaOH, we can regenerate basic resin. So these are the equations. So RCOO taken by Ca plus 2HCl gives rise to 2R. COOH plus CaCl2 and RCOO taken twice, Mg plus 2HCl gives rise to R 2RCOOH plus MgCl2. Similarly, base RCl plus NaOH gives rise to ROH plus NaCl. R2SO4 plus 2NaOH gives rise to 2ROH plus NaSO4. These are the byproducts we can remove as a waste. Okay, so this is the diagram for the demineralization process or ion exchange process. Okay, then in ion exchange process, all the cations and anions are removed from the water and the water produced as good as distilled water. So what is happening in this process? Whatever the cations present in the hard water and whatever the anions present in the hard water, they will be totally removed off. And whatever the water you are getting, it is as good as distilled water. How is the distilled water? There are no any ions in the distilled water. Same as like distilled water, you will get the water in ion exchange water. That's why this is called as demineralized or deionized. De removal of, there is no ions. Okay, and the process is called demineralization. Total minerals are removed off, total ions are removed off. That's why this process is called as demineralization. In this process, 99.5% pure water with hardness of 2 ppm is obtained. So just hardness 2 ppm is there in this process. After doing this process, the water is having this much ppm only, and it is 99.5% pure. So that is obtained. Okay, so this is about ion exchange process. Then come to the advantages of ion exchange process. So there are some advantages also. So first part we will see. In this method, water without any salts is obtained. Okay, there is no salts in this process. Whatever the water you are getting from this water, there are no salts. Okay, no residue is formed. So no residue will be formed here. So whatever the product residue is, that is not formed here. And it can be used for acidic or alkaline water. So here we can use acidic water or alkaline water, so nothing will happen. Whereas in zeolite process, we have to remove the acids and turbidity. So here we can use acidic or alkaline water, and it requires no heating. So there is no heating. Just we are passing the water onto the resins and reaction is taking place. Okay, it requires no heating. So these are the advantages of ion exchange method. Okay, and so what we have discussed in this period, ion exchange process and advantages of ion exchange process. The whole process, ion exchange process, with equations, with diagram and with explanation. And we studied advantages of ion exchange process. Next come to the objective type questions. So what type of objective type questions you may expect from this topic? A very simple question. So whatever if you perfect in this process, you can answer these questions easily. Okay, first question. Softening of water can be effectively conducted by. So first of all, softening means conversion of hard water into soft water, that is removal of salts from water. So effectively conducted by which method he is asking. So A, lime soda process, it is not in our syllabus. B, Clark's process, this is also not in our syllabus. Demineralization, permitted process. You have these two processes. Among these two, which is effectively, that means which one removes total salts from the water? This is the demineralization process. So answer is C. So these are also softening methods, but in your syllabus you don't have this lime soda and Clark's process. So C is the demineralization. Answer C. Demineralization process. By this process, you can soften the water effectively. Next, second question. In ion exchange process, cations and anions are exchanged by. So here ion exchange process, cations and exchanged by some ions. So what are those ions they are asking? Na plus Cl minus, H plus OH minus, OH minus H plus and H minus. So if you see here, option A, this is wrong. Option D, this is wrong. B and C. Okay. So here first what the cations and anions. This cation exchanged by anions. So cations are exchanged by H plus. Anions are exchanged by OH minus. So B is the answer. So here don't confuse this one. First cations exchanged by H plus ions and anion exchanged by OH minus ion. So answer is B. Then an ion exchange resin an ion exchange resin anion exchange resin is regenerated by. So how it is regenerated? Either HCl, NaOH, NaCl, KOH. Anion means basic resin. Basic resin is regenerated by adding base only. The HCl, wrong. This is NaCl salt. Here two bases, NaOH, KOH. So what is the answer? This is NaOH. By passing strong base, NaOH, you can regenerate anion exchange resin. So answer is B. Next, fourth question. Method used to remove permanent hardness of water is. So some methods are given. So which is the method to remove permanent hardness of water is asking. So A, ion exchange method. B, boiling method. C, Clark's method. D, Dumas method. So just now we studied now to remove permanent hardness. What are the methods? Two methods. That is zeolite and ion exchange. So in your option, what is the answer? Ion exchange. This boiling, Clark's and these all are not permanent methods. So this ion exchange method is a permanent method. This ion exchange method is the permanent method to remove this method to remove permanent hardness of water. So permanently we can remove hardness of water by this ion exchange method. So answer is A. So these are the some of the objective type questions you may expect from this topic in your entrance. Very simple questions, direct questions. Okay. Now questions. So what type of questions you will expect from this? So we studied only one topic, that is ion exchange question, ion exchange process, only one question. So that is for essay 5 marks question. Explain ion exchange process with equations and diagram. Okay, with equations and diagram. Need diagram. Okay, total regeneration. Sometimes they will ask for 3 marks questions if at all. Only regeneration, how acidic and basic resin are regenerated, like this also there. Whole process means 5 marks. Total equations you have to look at: ion exchange resin equation and ion exchange equation and explanation and regeneration equations. Okay, and you have to draw the diagram also. So that is for 5 marks question. Only explain regeneration of acidic resin and basic resin with equations, like that also they can. Then write advantages of ion exchange process. Okay, this not important. Sometimes they will ask. Okay, not frequently asked question means already I told zeolite and ion exchange process compulsory every year, any one method, either zeolite or ion exchange process for 5 marks question. Either zeolite or so you have to be perfect in both these processes. Okay, so with this we finish ion exchange processes. So these are the two softening methods to remove permanent hardness of water. So by these two methods, we can remove permanent hardness of water. So whereas temporary hardness is removed by just by boiling, And by adding lime water, that is called Clark's method, that is not in our syllabus. So those are temporary methods. The permanent methods, zeolite process and ion exchange process. Okay, with this we finished ion exchange process, or it is also called as demineralization. Remember this one. In exam they can ask, explain demineralization process. So don't confuse. Demineralization or ion exchange, both are same. So they can ask, so both names you should remember. So what is demineralization means? You should not what is this, you don't confuse. So demineralization or ion exchange, both are same. Okay. So if you have any doubts, we will clarify your doubts in the next class. So in the next class, once again, I will repeat this one, then we will go to further topic. Okay. Thank you, students.